Welcome and good afternoon. Thank you all for joining the first webinar of our Tarana Tuesday series. ngFWA is helping utilities successfully deploy high-speed broadband. Here to present from Tarana Wireless is their account executive, Tim Jaeger. If anyone has any questions throughout the presentations, feel free to add them into the chat and they'll be addressed at the end of the webinar. Tim, you're up.
All right, thank you very much. My name is Tim Jaeger. I manage the utility, municipal, and tribal practices at Tarana. And I'm going to go over today just a general overview of Tarana and how it was being deployed by some of the utilities. I do have one slide that will probably generate some questions in there, and it's one that I recently added yesterday about how we are helping some of the utilities fulfill their RDOF obligations. So with that being said, let me get started here. So today, what we're going to cover is some of the requirements of utility networks. Who is Tarana Wireless? What makes us different from traditional fixed wireless radios? How Tarana addresses the requirements of utility networks? Some third-party reviews on performance and security, some examples of deployments, how to engage Tarana Wireless, and then we'll address the questions. If you have any questions on how to engage Tarana or work, reach out to your Winncom account team, and they'll be more than happy to get us all put together. So some of the requirements of utility networks, and this is not all of the requirements, it's just some of the common ones that we're seeing out there, is radios or network gear have to be reliable and they have to be durable. The days of having the staff that is out there that can just support a wireless network are gone. And so you need to be able to have a deployment that's as close to deploy and forget as possible. Ability to work in harsh conditions. We've all seen marketing numbers and have been quoted with marketing numbers, but we don't live in a lab environment. So the radios that you deploy and manage have to be able to work in harsh conditions, both temperature, topography, and environmental conditions as well. They got to be easy to deploy. Again, you have limited resources to deploy these network assets and to maintain them. You got to be able to manage these networks remotely. A lot of these networks are deployed over vast areas, and you need to be able to manage from a central location. So if there is an issue, you are dispatching to fix that issue, not to determine what the problem is. Increased demand for data. Every day there's more and more demand for data. Everything from video is driving that to all the applications that are being run over these networks as well. In data security, nobody wants to be the next people on the front page. You've got to have a secure network for both internal utility networks and if you're offering broadband through the utility to your customers. So a little bit about Tarana. Tarana was founded in 2009, headquartered out of Milpitas, California. We've got roughly 500 employees and still growing. We are designed to address the $50 billion wireless broadband market globally. We do qualify for grant funding. Right now, this stat is a little low. We are passing close to 100 million locations with our production networks that we have out there with our various partners. And we're adding well over 2,000 remote nodes on a weekly basis. We have over 28 patents and more are pending. Some common challenges for fixed wireless access: single carrier channels, there's congested spectrum out there, low spectral efficiency, so it's very hard to let these networks grow and scale. Lack of support for near and non-line of sight. Again, we don't live in a lab environment. There's foliage, there's multipathing, there's motion that goes through the signal, and various other obstacles that are out there. Again, limited interference mitigation, not cancellation with traditional fixed wireless. And what that does is makes the deployments less stable and less ability to do large amounts of throughput. What Tarana has done, and when we work with the Winncom team to deploy networks and with their partners, we design to a minimum of 100 megabits down and 100 megabits up. And we do have deployments with gigabit per second download speeds on there. The reason we do this is the FCC earlier this year in March raised the definition of broadband from 25 megabits per second down and 3 megabits per second up to 100 by 20. And there are rumblings that it may move up to 100 by 100 as well. So what we're trying to do is to design a network with the longest possible lifespan out there. Yes, you can deploy in conditions that are less than 100 by 100, but that's what we try to design to. High capacity per base node for economic scalability. So with Tarana and with our radios, traditional business models for fixed wireless assets go out the window. And the reason is we support near and non-line of sight as well. So we also support high capacity per base node. Again, we've all seen the deployments of fixed wireless where at 40 to 60 max users out there, you are maxing out the capabilities of the system. With Tarana, you are looking at upwards of 200 connections per base node. In a lab, you're looking at 250. We are seeing common deployments on a base node of 150 to 180 remote users on that one base node. Consistent service quality through the deployment. One of the reasons that we are able to do this is we transmit and receive at the same power, unlike a 3GPP network where the bulk of the power comes from the transmission from the base node or the distribution site down to the remote nodes. High quality of service delivery and unlicensed. And the reason we do this is we have the ability to not mitigate noise. We have the ability to truly cancel that noise out there. And again, simple installation on a remote site. You're looking on a remote site of something very similar to a DirecTV or Dish Network type of install. So I mentioned earlier that we started off the company in 2009. We started to ship this product that we are doing right now in 2021 in October. So we spent a lot of time on engineering and designing out the products. One of the things that we spent our time on is we are not repurposing technology to build fixed wireless radios. We've designed a chip specifically designed for fixed wireless radios. We're not using the 3GPP chipset. And the main reason for something like that is it's great for what it was designed for your cell phones, but we've all been in a large venue when you're trying to send a text, make a call, send an email. You got signal, but you're unable to send it out due to the fact that the remote side is not transmitting at the same power as the distribution side. And Wi-Fi, again, great technology for what it's designed for, but when you repurpose the chips, the network overhead and the way that it distributes out bandwidth are issues for fixed wireless networks. So here's a snapshot of what our portfolio looks like now. We have the 3 gigahertz CBRS spectrum, an unlicensed 5 gigahertz spectrum, and the newly released 6 gigahertz spectrum that dips down into the upper end at 5 gigahertz as well. On CBRS and 5 gigahertz, we're commonly seeing download speeds of 500 and 600 megs per second, with upload speeds in the neighborhood of 140 megabits per second. On our 6 gigahertz product, because we have 4 40 megahertz channels to use as opposed to one channel, you are able to see upwards of 1.6 gigabits per second lab speed, with 1.5 roughly in the real world. Again, on CBRS and 5 gigahertz, you're looking at about 2.4 gigabits per second per base node, which is a 90-degree sector, or an entire 360 deployment of 9.6 gigabits per second. When you jump to the 6 gigahertz, we're doing 3.2 gigabits per second, or 12.8 on a tower on there. Again, base nodes are remote nodes in a lab of about 250. Real world, we're seeing common deployments of 150 to 180 on there. CBRS and 5 gigahertz, you're looking at 2 channels of 40 megahertz wide, so 80 total megahertz wide channels. They do not have to be congruent, so they can be in separate parts of the spectrum. Wherever you find bits of that channel that is noise free or has the least amount of noise. And the same thing goes for the 6 gigahertz, but it can jump up to 4 40 megahertz channels that you can then maneuver around. So again, we designed from the ground up. So when we were designing up, we wanted to hit as many of the check boxes as we could. So we work in near line of sight and non-line of sight conditions. We have true interference cancellation up to 40 dBs of noise cancellation. High throughput and spectral efficiency, you can use the same portions of your spectrum on all 360 degrees, where traditional fixed wireless, you have to alternate. So it does scale as well. Uniform service delivery, what that allows you again is to offer a much more reliable and predictable service. Spectrum reuse, because we have noise cancellation and we can again cancel out our own noise as well, you're able to use that spectrum on more than one site, so you can scale out your spectrum reuse and can be deployed rapidly. Again, you're looking at like a DirecTV or a Dish Network type of deployment on the remote side. We do have a network management system and called Tarana Cloud Suite. We have a dashboard that shows you the health of your network, your throughput that you're looking at, various alarms and metrics that you can track on there, including inventory, and you can even map where your network is and run tests on what links look like as well. We also have APIs that we can provide as well for third parties to manage the network and put it on a single pane of glass as well. Unmatched performance. Preseam is a third party that does fixed wireless testing out there for throughput. Tarana is down at the bottom. I've taken all the other manufacturers' names off of just because I'm trying to focus on what our performance is. And if you look at it, it's well over double of what the performance is of the competitors out there. There is a 2023 version of this as well. But again, this is a third party that does this testing. We do not do this testing as well. Also, security again. Nobody wants to be on the front page of the paper saying that they've had a breach. So we work with a third party called Coalfire, who did third party penetration testing, and no known risk existed during the times of the test on there. How do we do performance wise? This is an example of a network that we did. On the left is Tarana CBRS, and on the right is a competitor. This is deployed at the same height, same tower, same location, all the way through. And it shows you what your additional performance can be off the same vertical assets. So when I was saying earlier, we are a completely different business case than traditional. You don't have to deploy as many vertical assets on using a Tarana as you do with others to get the same type of coverage or even better coverage. So real world use cases. Utility wanted to deploy fiber so they can incorporate video surveillance along with their SCADA network out there. Due to cost and time restraints, they weren't going to be able to deploy fiber due to the length and coming in over budget. They were able to deploy Tarana utilizing our basic profile. We were able to meet the timelines that they needed to meet and under budget. And they now have over 100 sites on the Tarana just running video and SCADA network that they were using. Utility wanted to reduce costs that they were having, and so they decided they wanted to deploy AMI, automated meter reading. And so what they started to do is, as they were deploying the meters at the houses, they were able to also offer high-speed broadband to these customers. So what it did is it generated another revenue source for the utility at the same time of being able to service that utility in a much more economical manner. And again, utilities offering internet rural connectivity. A lot of the smaller co-op utilities that I'm working with are looking for ways for other revenue that they can deploy for their customers as well. So again, they were able to offer high-speed broadband networks to their customers using the Tarana infrastructure. So one of the big things that we've seen recently is we are working with various utilities and various entities to meet the federal and state grant fulfillment. It is making news right now that there are some entities starting to give back and default on RDOF locations. This is problematic for many reasons. One, the BEAD maps have already started to be formed, and these RDOF locations that are being defaulted on now leave holes for that in those BEAD maps as well. And we are not just working with the federal, we're also working with state grants as well, not just RDOF, but Reconnect, Rip and Replace, and other grants out there to do this. And we're not coming in to customers saying, hey, you bid this using fiber to the home, use Tarana instead. We're saying, let us help augment your fiber to the home deployments, where we can then hit some of the harder locations or locations that are not necessarily economically feasible using fiber. And again, you stay in good graces with the federal government and the state broadband offices in case you do have BEAD or other grant proposals out there as well. So how do you engage with the Tarana team? So again, I work in utilities, municipal, and tribal markets. My email's here, tim@taranawireless.com, very easy to remember. The phone number that's on there is my cell number, so I do keep that with me. I do travel almost every week, so if you shoot me a text or give me a call, I will call you as soon as I get off a plane or as soon as I'm out of the meeting or available to talk. Charles Bird is the sales engineer that I work with, and again, his email's also simple. It's charles@taranawireless.com. He is on the East Coast, based out of Georgia. So we cover pretty much the whole country in normal business hours. But again, you have our cell numbers and you can reach out to us at any time. But whenever possible, reach out to your Winncom account team. They can answer most of your questions and again, can engage us if you want us to work on a specific project with you. So Dawn, at this point in time, are there any questions that have come up?
I do not have any questions on my end.
Okay. Let's just give a minute or two just in case someone is like me and types very slowly. So with this, we are doing an event next week with Winncom in Las Cruces, New Mexico, showing what that network looks like in a real seeing is believing, and being able to go out and actually see what the performance is in live. Also, Winncom is one of our training partners. So if you're interested and want to get trained on Tarana, again, please feel free to reach out to your Winncom account team. They can get that all put together for you.
Well, wonderful, Tim. We have a few questions popping in now. What is the technology? Wait, what is the technology that is used in the radio? Are they 4G or 5G?
It's neither. We are a terrestrial land base. We are not a cellular based system whatsoever. So there is no core or anything like that. We will just plug directly into a switch and you can make all your configurations via the cloud.
Okay, wonderful. Excuse me, there is a question asking, we'll be providing a copy of the slides. Yes, there'll be an email that goes out following the webinar that'll have a copy of the slides. Tim, you say you're designing to deploy 100 to the RN. Can you speak to the different capacity profiles? I'm hearing there are 3 different profiles. Is this the case?
We have a total of 6 profiles. They range from 4.5 megabits per second down, 1 megabit up. And then our long distance profile is 4 megabits down to 1 megabit up. And then I think we have a 2.5 megabit down for every 1 meg up. And then the profile that I use the most is 1.75 to 1. And the reason is it gives much more upload speeds, and a lot of the deployments that we are doing require higher upload speeds. We are working on some that are even trying to get it more close to symmetrical.
Okay, great. Are there any easy rate reach specs such as MBP, megabits per mile?
It's too hard, and there's too many variables on megabits per mile. You're going to be, a lot of them are depending upon what the noise environment looks like, what spectrum you're using, what profile. So it's tough. But what we would be more than happy to do again is work with the Winncom team to develop up a heat map for you for your individual deployments.
Okay, and we got one last question for you. Oh, no, we got another one that popped in. Does Tarana support N900?
I will have to get back to you on that, but I will have an answer by the end of the day for you on that question.
Okay, and then the last question I have is, can you deploy multiple profiles, or do you want to stay similar in the profiles across your network to help with sync?
So you can deploy one profile per BN. So if you have 4 BNs deployed, you can do 4 different profiles. Does that make sense?
That's great. Okay, that is all the questions I have on my end.
All right, and I will get you a question, answer on the N900 question.
Okay. Thank you, Tim. And to everyone else, as a quick reminder, we will be providing a copy of the slide presentation and video when the upload is complete. So please keep an eye out in your inbox for these, as well as registrations for the next Tarana Tuesday dates. So I hope you all have a wonderful rest of the day. And as always, thank you for joining.